Hello and welcome to Moshang USA channel. Moshang comes from an ancient Chinese poem, which means down to earth. We are Chinese and English bilingual channel. Our friend Miss Tom Hafer is going to continue the climate topic.
We're going to continue the discussion of how to ameliorate global warming. And we've had 3 discussions on this. And today I've come up with a little more quantification on how much we could help it. So I'll get to that, but I'm actually going to start by reviewing what we have already done. This is how to reverse global warming while you're still alive. So the first thing you have to know is that all of the current approaches will not reverse global warming. In fact, it will keep getting hotter just doing the things that we're doing. Because of that, I'm going to give you the bottom line up front, and then you can scroll quickly through the rest of this presentation if you like, and you can stop at the places that are of interest to you. But here's the bottom line. Using current approaches, the things that we're doing, for example, under the Biden environmental bill, it is going to get hotter for the rest of your life. Right now, we're at about 1.4 degrees C above pre-industrial levels, and it's likely to go to a whole nother degree above that. And what we're doing now, reducing emissions, cannot reduce temperature, and I'll show you why. It doesn't mean that it shouldn't be done. It should be done, and I'll tell you why that also. However, it has to be done in conjunction with an approach that can reduce temperature in the near term. And I call that approach global shading. And this presentation will show you what that means and how to get there. What is global warming doing? Well, it's getting hotter, but it is also supposed to be bringing floods, droughts, hurricanes, and tornadoes. And these are all likely to get worse if global warming continues. So how bad will it be? Well, here is our old friend, the MIT En-ROADS climate model. And this is the base case. And En-ROADS is a model that allows you to play with all these variables down here, what the energy supply consists of: coal, oil, natural gas, nuclear, some magical new new zero carbon energy source, vehicle electrification, Teslas and so on, and all deforestation, afforestation, etc. And over here, it shows you how much the temperature is going to go up. And so here we are in 2024 at about 1.4 degrees above pre-industrial times. And over here, it shows you that at the end of this century, in the year 2100, when we're all very old, some of us won't be getting any older, it's going to be about 3.3 degrees. So another degree and a half above where we already are. So that's probably just going to make things worse. So we showed you previously a graph that looked like this, where we said, okay, suppose that we look at what the Biden bill is doing and we max out renewable energy, so windmills, solar panels, and so on, and electrification of vehicles, Teslas, EVs, and so on. And not just us, but the whole world does this. And so how much does it change the result? Well, hardly at all. Everybody finds this surprising, but it only reduces the warming from about 3.3 degrees to about 3.0 degrees. What would worldwide electrification of vehicles look like? Well, right now, EVs are about 3% of the California vehicles. So this is what gas lines looked like back in the 1970s during the Arab oil embargo. This is what EV lines look like in California right now. Now imagine that things get 30 times worse. What are those lines going to look like? Well, previously, we were criticized by some for our use of the En-ROADS, looking only at EVs and at renewable energy sources. And they said, well, you didn't pull all the levers. So here we are, pulling all the levers. So now we have minimized the use of coal, oil, natural gas. We've maximized bioenergy, maximized renewables, nuclear, invented some magical new zero carbon energy source, increased electrification of vehicles and their efficiency, electrification of buildings and their efficiency, got rid of deforestation, and even cut methane by half, which is probably impossible because it's mostly from agriculture and wetlands. And what happens? The temperature still goes up over another half a degree. It's still going to be warmer at the end of your life. And that's if the whole world does all these things, which is ridiculous. It's not going to happen. So why is it still getting hotter? Well, it's simple. Why doesn't the temperature go down when we emit less CO2? Well, it's because it's like putting blankets on a bed. CO2 acts like a blanket over the earth. And as long as we keep putting on more blankets, you will not get cooler. It's not until you start taking off blankets that you get cooler. And that's not what reducing emissions does. So we've looked at a little more, how much carbon dioxide are we adding? Well, over here on this side is a graph of worldwide CO2 emissions. And look at the slope of it. It's going up and up and up and up. And over here is a graph from the United Nations, the IPCC report, that shows what we would have to do to get only 2 degrees of warming overall, the most favorable case that I showed above. We would have to cut emissions drastically and quickly. By 2040, we would have to be down by practically a half of what we already emit. If anybody thinks that that's going to happen, they're crazy. So we're going to look at a case that's a little more likely. We'll take all of those same parameters and we'll follow this curve right here. And here it is. So the most likely case is this, where we've taken all those same things that we modified, but cut their values in half. And you get to about 2.4 degrees. In other words, about a whole degree warmer than we are now. Is there a way to get around that in the near term? Well, there is, because this is a graph of that same global surface temperature going up. And this shows what happened when Mount Pinatubo in 1991 threw a bunch of ash and sulfur dioxide up into the atmosphere. The temperature immediately cooled by about a half a degree, just from a few tenths of a percent of solar blockage. Over here is where Mount St. Helens and El Chichon erupted. Same thing, about a half a degree. And over here is a different phenomenon. The question was, when we were emitting all of this carbon dioxide back in the 50s and 60s and 70s, why didn't the temperature go up very much? Well, it was because those same industries were emitting soot. So paradoxically, as soon as the EPA started cleaning up all of the soot from our industries, temperature started going up. So now we have a new climate problem. So is there a way that we can simulate this without throwing a lot of environmentally damaging chemicals up into the atmosphere? Well, here is one concept that was discussed in the New York Times not too long ago, the space shield. So way out here, about 1 million miles from Earth, at a position called L1, they would erect a giant solar shield. Now, this is really big. It's about the size of Argentina, if you can believe that. So this is a daunting technical challenge. But if they did that, and if it stayed there, and if everything worked, it would cast a shadow on the Earth. Now, this shadow is way too big, but it would shield the Earth from a certain percentage of the sun's light. And that would, in fact, cool the Earth. There's a problem with that. That would affect every nation on Earth. They would all have to agree to it. We can't even get every nation on Earth to condemn the Russian invasion of Ukraine. How in the world are we going to get every nation on Earth to agree to a solar shield, especially nations like Russia that want it warmer and that sell lots of oil and gas? So are there other approaches? Well, here's one. This is cloud brightening. So here, these giant pumps are throwing salt crystals up into the air. And the idea here is that they're going to brighten the clouds, make them whiter so that they will reflect more sunlight. Problem with this is that it's going to produce salty rain, which is going to kill off agriculture. So even though this is being tried, it's a non-starter. Is there another alternative that could work? Well, yes, balloons. This is the NASA Athros balloon. This is a giant balloon. This balloon is 400 feet across. And we would make them like an umbrella. So not actually transparent like this one is. They would be way up in the stratosphere, way above any aircraft, barely visible at all. And if you put up millions of these, they would have the same effect as a space shield. They would cool the Earth. Now, would people get freaked out by balloons overhead? Well, first of all, these would barely be visible. You'd have to look very hard to even find them. But to answer your question, here's London in World War II. And these are what was called barrage balloons. So they impeded the flights of enemy bombers and fighters over London. And not only were people used to these, they liked them. They gave them nicknames, Lord Atherton and Thomas Aquinas and things like that. So people get used to these things pretty quickly. So how much good would this do? If we used 300-foot diameter balloons, not quite as big as the Athros balloon, and put 1 per square mile over the entire Earth. I'm not going to go through all the math. You can find that down here in this paper, but I compute it 2 different ways. And at the end of the day, it would cool things off by about a half a degree C. So that would be quite significant. That would reduce a rise of 2 degrees C to only 1.5. So it would cut back, for that best case, the climate from what it would be in the year 2100 to what it is now. But we can actually do better than that. So how? So instead of putting balloons over the entire surface of the Earth, you'd focus them here in a band around the equator where there's more what's called insolation, incoming solar radiation. And that would improve the overall effectiveness by about 50%. So now we're back to about -3/4 of a degree centigrade improvement that it would make. So what does that mean? Well, here we are in 2020. Well, this one only goes to 2022, but here's the temperature rise over time. And here's where we are now. And knocking off 3/4 of a degree would put us back to the way that things were sometime before the year 2000, when things weren't nearly as bad as they are now. So what it would do is it would buy us time. However, there's a problem. Any solution that affects the entire world would have to be agreed to by every nation on Earth. How can we do that? Is there a solution to that problem? Well, the answer is yes. So the United States could do this on a US only basis. So if we focused on this area around the southwestern US, it's about 700,000 square miles. If we put up, instead of 1, 3 balloons per square mile, that comes to about 2 million balloons. Now consider that we make about almost 10 million automobiles every year. So 2 million balloons is not that hard to produce. And it would result in about a 2 degree centigrade reduction in temperature over this very hot, arid area. And furthermore, as the air gravitated east, weather in the US tends to go from the west to the east, these other areas of the United States would get some benefit from that. Now, that would only be for the United States. That wouldn't cool the rest of the world. But if the rest of the world saw how this worked in the United States, then soon they might also copy that. And soon we might get a true international agreement. Summary: the world will continue to get hotter on the current course. What we're doing now is good. We should be cutting back on carbon dioxide emissions because that will benefit your grandchildren. But the balloon deployment buys us time and flexibility. And hopefully a US only solution would be copied by many other nations. The balloons start working right away, not 50 years from now. They're environmentally benign. There's no soot, particles, salt in the air. It's scalable. If you want it cooler, you put up more balloons. It's way less expensive than what we're doing now. It's controllable. You can cluster or disperse the spacing, put them over areas where there aren't any clouds, where the sun is the fiercest. It's reversible. If you don't like what's happening, you bring the balloons down at any time. It's far less impactful on the environment and on your lifetime. You can take your family on a vacation on a jet plane without feeling guilty. It's potentially profitable because these balloons are actually like low-hanging satellites. So you can put communications systems on these and cover areas that are hard to get at, such as mountaintops and valleys and Indian reservations and things like that. So the bottom line is this: what are your other options? There isn't anything else that's going to produce a near-term reduction in temperature. So wouldn't this be worth a try? For a few tens of millions, you could put up dozens of balloons and see how well it works and answer some basic engineering questions like, how long do they last? How cheaply can they be made? How easy are they to control? And all this would cost about 1 minute's worth of US government spending at its current rates. So that's my presentation. If you have any questions, you can ask them in the comments below, and Dr. Liu will put this URL if you want to read the paper that will answer questions like, what is the mathematical derivation of this? Thank you. That's all for today.